Hello and welcome to my YouTube channel. My name is Yasser Khan, and in this video I will be going through the hexadecimal conversions. Before we get started, it's important to know that in your exam you are expected to be able to convert hex to denary, binary to hex, hex to binary, and denary to hex. The hexadecimal number system. Binary is a base 2 number system, whereas the hexadecimal is a base 16. As you can see from the table on the right hand side, hexadecimal has 16 different numbers and characters. Hexadecimal can be used to represent much longer binary numbers. One hexadecimal digit can represent 4 bits, which is equal to 1 nibble. Hexadecimal number system is used because it's easy for a human to remember a hexadecimal code compared to a binary number, and it's also easy to spot errors in a hexadecimal code compared to the other number systems. It is important to know the different place values of the different number systems. Here we are going to look at the different place values of the denary system. In the denary system we have units, we have tens, and we have hundreds. So if we were to put in 111, the answer here would be 111. In the binary system, if we were to put in 111, the answer in this system would be 7. And in the hexadecimal system, which we are focusing on in this video, if we put in 111, the value would be 273. How the hexadecimal system works. As you can see from the tables below, that there are 2 columns below. Because the second column is 16, we have to count to 15 in the ones column before we can actually place a 1 in the 16s column. Placing 2 digits in any number system is not allowed. Hexadecimal number system uses letters to avoid having 2 digits in one cell. So as you can see, this 15 would not be allowed in the hexadecimal or any other system. Instead of having the 15 in the hexadecimal system, we would convert this into the letter F. Some of you might be thinking, how did the number 15 turn into the letter F? As you can see from this table, the number 15 is equivalent to the letter F in hexadecimal. In your exam, you will not be provided with this table, so it's important to remember this. As you can see, from 0 to 9, we have numbers, and when we get to number 10, it's equivalent to A, number 11 is equivalent to B, C, D, E, F. Just remember that the letters start after 9. So 10 is A, B is 11, C is 12, and so on. Let's look at some conversions. Let's start off with converting the number 14 into a denary number. So we've got the number 14 here. As you're aware, in hexadecimal we have a 1 and a 16. So what we would do here is multiply the 1 by 16 and 4 by 1 in order to convert it into a denary number. So 1 times 16, nice and easy, 16. 4 times 1 is 4, and we add them up together to get the total, which is 20. Let's try a bit more challenging question now. Convert the hexadecimal letters AC into a denary number. So, as we said before, we've got the letters A and C. A, as you can see from the table on the right, is equivalent to the number 10, and C is equivalent to the number 12. So what we will do here is multiply A by 16, which is 10 by 16, and multiply 12 by 1. So 10 times 16 is 160, 12 times 1 is 12, and the answer is 172. Here we're going to convert the denary number 18 into hexadecimal. To do this, we need to know how many 18s fit into 16, and then the remainder goes into the ones column. So 18 divided by 16 is 1, remainder 2, so your answer here is 12. Convert the denary number 56 into hexadecimal. Again, 56 divided by 16. How many 56 go into 16? And the remainder into the ones column, which is 3, 8. One more, let's convert the denary number 189 into hexadecimal. So here again we would do 189 divided by 16. And the answer is 11, remainder 13. As you can see, 11 is equivalent to the letter B and 13 is equivalent to the letter D. So your answer will be B, D. Now we are going to convert the binary number 00110111 into a hexadecimal number. To do this, what you need to do is split the binary number in half, where you will have two nibbles. One will be the left nibble and the other one will be the right nibble. As you can see, the place values have changed from 1, 2, 4, 8, 16, 32, 64, 128 to 1, 2, 4, 8 for both nibbles. Then we total it up and we get our answer. So the left nibble is 3 and the right nibble is 7. Let's have a look at another conversion. So we are going to convert 10110101. First step is to split it into nibbles. So we've got the left nibble and the right nibble. The left nibble is the first half and the right nibble is the second half. We place our values and we total them up. So 8, 10, 11, which is equivalent to the letter B. And then we've got 4 and 5 in total. So the answer is B, 5. Convert the hexadecimal number 17 into binary. What we do here is each digit represents a nibble. So the left digit represents the left nibble, the right digit represents the right nibble. So we've got our left and right nibbles. So 1 is 001 in binary, 7 is 0111 in binary. What we do next is combine the two nibbles together to make our binary number. Here's another hexadecimal conversion, but this time it's converting hexadecimal letters E and A into binary. So as we mentioned earlier, first thing we do is split them up. But before we do that, it's important that we know the value of each letter. E, as you can see from the table on the right, is equivalent to the denary value of 14 and A is equivalent to the denary value of 10. So we split them up into nibbles. E will be our left nibble, A would be our right nibble. And now we need to ensure in the left nibble we have 14 in binary, so that is 1110. So it's 8 plus 4 plus 2, which is equal to 14. In the right nibble, we need to ensure that we have 10, which is 8 plus 2, which is equal to 10. Once we've done that, we join the two nibbles together to get our conversion. So for E and A in hexadecimal, converted to binary, it is 1, 1, 1, 0, 1, 0, 1, 0. It's time to check what you've learnt so far. The answers to these questions will be up in my next video. What is the denary base 10 equivalent to the hexadecimal digit E? What hexadecimal value is obtained when the two hexadecimal digits C and D are added together? The memory of a computer contains data and instructions in binary. The following instruction is stored in a location of the memory. Convert the instruction into hexadecimal. Explain why a programmer might prefer to read the instructions in hexadecimal rather than in binary. Give two uses of hexadecimal. A register in a computer contains binary digits. The content of the register could represent a binary integer. Convert the binary integer to hexadecimal. The content of the register could represent the ASCII value for the single denary digit 7. Write down the ASCII value for 9 in hexadecimal. Explain why hexadecimal is used to represent binary numbers. The display screen shows a hexadecimal error code E04. This error code means that the water will not empty out of the washing machine. Convert this error code to binary. State why hexadecimal is used to display the error code. The IP address of a computer is stored as a set of 4 8-bit binary numbers. The network administrator converts each binary number into hexadecimal. Complete the table to show the hexadecimal equivalent of the binary IP address. The first number has already been converted. Diraj identifies 3 hexadecimal numbers. Write the denary number for each of the 3 hexadecimal numbers. Hello and welcome to my YouTube channel. My name is Yasser Khan, and in this video I will be going through the hexadecimal conversions.